We're going to do some generalizing about slopes, and in particular we're going to look at the relationship of the slopes of two parallel lines versus the slopes of two perpendicular lines, how they relate. So let's begin with parallel. So what are parallel lines? Two lines are parallel if they run side by side and never intersect, never touch. Okay? So let's look at an example of a line, and then we'll consider a line that's parallel. So let's graph some random line. Maybe it looks like this. Think about its slope. Now, I'm not actually going to calculate the slope of this line necessarily. You can see my grid is not even labeled with units or uh, intervals of 1, 2, 3, 2, 4, 6, 8. We don't know what the scale is on this graph, so I can't do that. But I can look at the slope in general. I know I can pick any 2 points. So maybe I'll start with this point, and I'll find my rise. Maybe I'll rise this much, and then I'll run maybe this much. And so I've got 2 points, and I've got my rise and my run. Now what I want to do is consider any line that's parallel to this. So what I'll do is use the software to help me out with that. So any line here, you can see this line's parallel, this line's parallel, this line's parallel, this line's parallel. All of these lines are parallel. So let's fix it here. Let's put it maybe right here. We can see that these two lines are parallel, and in fact, the rise of this line is equal to the rise of this line, and the run of this line is equal to the run of this line. So what we can say is, let's see here, if two lines are parallel, their rises and runs are exactly the same. Okay, we were able to see that in the graph. The rise was the same, the run was the same. Well, if the rise and the run are the same, they have the same slope. Okay, so that's important. So any two parallel lines have the same slope. That makes sense. They have the same tilt, the same angle. So, for example, let's look at an example here. If line L1 has a slope of -3/5, for example, then any line parallel to L1 also has a slope of -3/5. Okay, so just wanted to see concrete numbers here. The slopes are exactly the same when you're dealing with parallel lines. Let's do the same analysis on perpendicular lines. It's a little trickier. Two lines are perpendicular if they intersect at a 90-degree angle. Okay, so let's draw a picture of a line and then look at a line that's perpendicular. So let's take the line that we saw before in the previous example. We'll start with this line, and I want to get a perpendicular line. So again, I'll use the software to help me out. Now, this is not a perpendicular line, but if I were to rotate that line 90 degrees, now the line is perpendicular to what we started with. So let me show that now this is a 90-degree angle. So this line's perpendicular. So let's look at what happened to the rise and the run. The rise here in red, highlighted in yellow, it's vertical on the initial line. But when we look at the perpendicular line, it's now a horizontal measurement. In fact, it's now the run of the slope. Similarly, the run of the initial line was horizontal, which is now vertical on the perpendicular line. So let's see if we can say what's happening here. If two lines are perpendicular, then their rises and runs are swapped, right? We can see that yellow was vertical, now it's horizontal. Green was horizontal, now it's vertical. Okay? So what does that tell us about the slope of perpendicular lines? So the slopes of perpendicular lines have the rise and the run switched. So instead of being rise over run, it's like run over rise. That means they are reciprocals. That's what it means when you flip a fraction over. So the slopes of perpendicular lines are reciprocals. Now there's something else going on here. This first line we looked at had an uphill slope, right? It's going uphill. The second line we looked at had a downhill slope. Well, we know what that means. An uphill slope means it's a positive slope. And a downhill slope means it's a negative slope. So not only are these slopes reciprocals, but they have opposite signs. So in addition, if a line slopes uphill, meaning it has a positive slope, then any perpendicular line slopes downhill, meaning has a negative slope. So perpendicular lines, perpendicular slopes, let's say, have opposite signs. Okay, so let's summarize about perpendicular lines. The slopes of perpendicular lines are reciprocals. We already said that. And they have opposite signs. So there's two things going on here. Okay, so let's look at an example. Well, first of all, let's put that conclusion. Let's set it apart a little bit. That's what we need to figure out. That was what was important here. Let's see an example of that now. If line L1 has a slope of, let's say, -3, which, by the way, -3 is a fraction, is negative, and then 3 is a fraction is 3 over 1. So if line L1 has a slope of -3, then any line perpendicular to L1 has a slope of, well, what I need to do is I need to find the reciprocal. So I need to flip 3 over 1. So that would give me 1 over 3. And I need the opposite sign. So it was negative, so now it's positive. So it would have a slope of positive 1/3. Okay? So now you can see what reciprocal means, and you can see how they have the opposite sign. Reciprocal, flip it over, opposite sign, one is negative, one is positive. So parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. That's a quick way to say that, opposite and reciprocal slopes.